So, good afternoon, ladies and gentlemen. My name is Esko Tahkola. I do come from CiDRA Minerals Processing, and I'm here to talk about how to benefit from the process diagnostic features of our Sonartrac Flow monitoring system. Let's take a look at the cash flow, where the money comes in this business. There's the head grade that we can't affect by flow measurement. Then there's the production rate, availability of the process uptime and the recovery and quality, and you minus the costs. So the red ones are those ones that we can affect by our flow measurement technology. To maximize the rate, so the throughput, recovery and availability, so the uptime, you must be able to run the process on stable optimal conditions. So you must minimize the disturbances in the production rate. Stable production rate is also essential for the grinding efficiency and optimal usage of chemicals and additives, and thus it's affecting the cost to produce. You can see the effect also in this tailings treatment and wastewater treatments. Separation processes are establishing the recovery and quality of the valuable minerals, so stable conditions are always essential for these. Process uptime is maximized if process disturbances can be minimized, as those will cause direct losses on production due to blockages, lowered yield in the separation stages, and indirect losses through increased need of maintenance. So, CiDRA Sonartrac diagnostic information on process can be used as a tool for online detection of process disturbances to enable instant and corrective actions by operators. So we are talking about the newest flow measurement technology, Sonar. That is the only technology that also simultaneously can measure the volume occupied by air bubbles within the pipe and correct the errors the bubbles are causing for density measurement. We do have also gas hold-up measurement for flotation optimization. So Sonartrac looks like this. It's a sensor mat that we wrap around the pipe. Onto the pipe we have a sensor cover and transmitter, and you get the information to the process control system. Installation is easy. You just clean the pipe and install the device, which is light instructs, and the total installation time is about a couple of hours. There's an intensive data logging feature capability that can include the data history with 2-second intervals for a month. And we do have a specific analysis system for that. It's the same device for whatever is flowing, and so you don't need different kind of versions for different kind of flowing materials with this technology. If we look at the flow measurement, so all flow measurement technologies principles are calibrated for fully developed water flow in calibration facilities. It needs that bath tube type of flow velocity profile. For what is needed for that kind of to reach that kind of flow velocity profile, you can see here that you need quite a long straight distances, pipe sections before and even after that. So how many positions in your process are really fulfilling this request? So usually the processes, these flow conditions are far away from this fully developed flow. So a little bit more information on that flow model, what's happening in the pipe, is needed. How do we get this diagnostic info on the flow? We do have there 4 different parameters coming, or flow measurement quality, which is describing directly that what is the flow model there, how close and how stable it is. Sound pressure level and sound spectra are telling you that how your pumping is behaving. Is it stable, or are there changes to compare to the earlier statuses? Then the air gas and gas content measurement, only technology to measure the volume of gas in the pipe. And process temperature is also available from our technology. Our information is coming from the turbulences of the flow. And because of that, we can see how they are affecting behaving there inside the pipe. So if we take a turbulence of certain size, we get information out of that, and we make a map to put the frequency of this information on the vertical axis and wave number on the horizontal axis and place the information there. Then if we take another size of turbulence, we get a response at higher frequency and so on and so on. Of course, the whole turbulence spectra that is propagating the solids inside the pipe is detected simultaneously. If the flow model is this kind of a homogeneous, fully developed turbulent flow, this forms a linear ridge on this map. And the slope of this ridge is directly telling us at every position that at what velocity each size of the turbulence is propagating inside the pipe. And that efficiently tells us that what is the flow model inside the pipe. So once again, bigger turbulences are giving their response in the lower section of the slope, and the smaller ones are at the higher section. And if this is nonlinear, so we can just simply by selecting the frequencies, modify and optimize the measurement according to the real flow model inside the pipe. So we get good measurement results even in this kind of positions where the straight distances in the piping sections are not available. So this flow measurement quality information is available for the customer as a direct current output or Profibus signal or whatever. And it gives online information for operator that when there are disturbances in the flow in your process. And the operator can do immediate corrective actions. Combined with the other Sonartrac information, you can define, is it caused by flow segregation, and then you can prevent the blockages in the lines. According to one study, about 1% of production time can be lost due to the line blockages. So it's a significant factor affecting to the total process time. Some customers use it as a rough indicator of oversized particles, because segregation is happening when the particles comes too big and heavy to be carried forward by the flow. And there can be air or gas, there can be pump problems, and the other information provided by GVF and SPL can then define that. What is the reason behind that? Here we see the situation at flow segregations. So the carrier liquid is flowing faster here, but the solids are starting to form their own ridge. So immediate actions are needed to prevent the density pulsation that this kind of segregation is causing in every process and causing the risk of line blockages. Here is an example from a customer, so we can see that the flow measurement quality value has dropped here because segregation, and after that even the flow velocity drops, and then the pump starts to rush it to the next stage, so the density pulsation is ongoing. Sound pressure level is informing on the stability on the sound source. So typically this is the pump. And based on that, you can detect the needs for pump maintenance immediately. Here we see a situation where we do have the sound pressure level here, and we can see that there are sharp drops. This is something about the 4-hour trend here, and you can see that there are sharp drops in the sound pressure level. And there's the flow measurement quality factor, and we can see that those drops are causing severe problems to the flow model, so disturbances in the flow. Based on this, we can define that there's an immediate need for pump maintenance. Entrained air measurement, we are measuring this based on the speed of sound, and this goes basically so that we can measure it up to 20% of bubble volume. Here we can see an example from a flotation feed. So there has been severe problems to control that flotation stage, and no wonder. If we look at this, this is a 2-day trend, and you can see that the air content has gone up even over that 10%, which has been set to correspond 20 milliamp output here in this process. So for hours, there has been over 10%, up to 10% air going into the flotation tank. No wonder it's difficult to stabilize the operation of that. Based on this measurement, we can trace back where the air is coming from, prevent it, and even correct, take it into account in the balances and operational guidance of the flotation stage. Based on this bubble measurement, we of course correct also the errors it's causing for nuclear density measurements. And the closer the density of the slurry is to water density, the bigger error is caused by 1% of air. If the slurry density is only 1.1, so 1% of air is causing already 10% error in your mass balance and production rate. So the user benefits on the continuous air content information is that you get the real production rate correctly measured, and it improves your process controls. Operators are immediately knowing when the air or gas is part of the problem of the process runnability. So they make the corrective actions in the process controls. And of course, you can trace back where the air is coming from. You can minimize and even prevent the aeration in the process by some simple measures. And you can develop unified best practices to run the process in those disturbance situations. Then, of course, you are minimizing the recovery and runnability losses caused by air disturbances in guidances of separation processes. And you can know how much there is air in your process. Air is often neglected as a disturbance factor in processes. Then the user benefits on the flow model information. The measurements with Sonartracs are optimized according to the real flow model at the installation positions. All other flow meters are always assuming that there's a fully developed turbulent flow. So you will get better accuracy and repeatability even in positions without these long straight pipe sections that you practically never are having in real process conditions. Variations in flow measurement quality factor indicate the changes in flow model, and I think the key issue there is the prevention of line blockages and air cost distortions in the process line. And based on this, we see the flow model, so we can offer also support already in the pipeline design phase, how to design the pipeline so that the measurements have, so density measurement and flow measurement have the best possible capabilities to work as well as possible. So we are willing to come to help you in the piping design to avoid those typical errors that are causing problems for all measurements. And of course, the basic performance. Here we see the comparison between Sonartracs and magnetic flow meters in the same pipeline in the start and the end of the line. Two similar meters, and the difference of, between the readings of the meters is shown here. So the sharper the distribution is, the better is your production rate control and the more accurate is your mass balance. And this is measured by our customers, not by us. And it's a very typical picture. Even here, the material ore is not magnetic. It would be even bigger difference in favor of Sonar if there would be magnetic components in the material. So, do you allow that kind of process variability that old magnetic flow meter technology is giving to you all the time when you are running the process? How much does that cost as production yield losses, downtime losses, chemical additives and energy cost, maintenance, and measurement replacement cost? There are some customers that have selected our technology. Not all of them are utilizing all of these features of these, but a good portion of them. I thank you for the attention, and you welcome you to visit our stand at the Zinc Hall for further discussions. Thank you. Any questions?